Hey there guys, and welcome back. So, a number of things here to talk about. First thing off is that I did end up getting this fixed. Actually, I'm on the wrong page right now. This is not the sample. There we go. What was happening with the TKinter Canvas, it appears, and this is not something I recall from TKinter, but it's been a long time since I've used it, is that the sprites were actually just getting smushed in. Basically, our canvas size was way too small. We just copied over from back over here, 384 by 216, and the canvas just basically wasn't big enough. So if I go ahead and run this again right now, should pop up. Yep, there you go. So you can see it, and you can see the stream text is in the correct place right now. So that is fixed now that I've got it to a larger size, so everything can fit. And this 1920 by 1080 was what I was going to end up with to begin with, because again, this in theory was going to go on stream. So everything's good, just a minor issue there, and honestly it wasn't even a coding issue so much as just the way it works. So that gets us caught up, and now we're on to what the heck we're doing right now. And I was gonna dive into this yesterday, and decided to push it off for a day for two reasons. One is yesterday after dinner I just kind of hit a huge speed bump and my energy levels went through the floor. So I was like, you know what? I'm feeling super tired all of a sudden now that I'm done dinner, and I'm not gonna be able to stream like this. So that was number one. Number two was that there are basically two things I want to get done at this point. One is actually get this thing up and working, and the second is implementing the AI and whatnot, the automation of it all. So those two things in theory should be done at the same time, or can be done at the same time I should say, but they actually can be somewhat exclusive. So I could just put together some basic AI and some basic whatnot and have the thing up on stream, you know, by the end of this session, in theory. In one of those things, depending on how quickly I could. But that's not really too complete, you know. It would just be, let's throw this together to get it working kind of deal. It's not really a complete program at that point. We could always double back, to be fair. We could always double back and then catch back up, but I think just for the sake of completeness, we are going to go ahead and try to fill in some of the background stuff right now, and hopefully by the end of the stream we end up with something, you know, it's not just background stuff. We end up with something over on here. Let me swap over to this guy. This would be the thing that's actually running on my streams. This is the program I set up. One of those things, I don't think we've gone over setup.py really on this channel, but just the most important thing to note here is that I set up console scripts here, and this actually, so one of those things, just put the three scripts in three different things instead of having them one. Just a preference there, doesn't necessarily have to be. But regardless, like as you can see, all this here, so these are the functions here, and then I also got that copied into pies to import into, just to keep the code, you know, this code base a little bit simpler. That's all I did there. But point being is that we may or may not get there, and when we start talking about this stuff, I'll explain some more about console scripts and whatnot. But for the time being, let's get the other stuff in here. So AI is kind of funny, because one of those things, it can honestly be whatever so long as it works, right? We don't have to go too hog wild on all this. For example, I can see here that back when we first set up entities in engines, we got the category list here, and that honestly is not going to be terribly useful in our current demo. Sprite entity, one of those things, technically yes, but also at the same time a little bit overkill. And it's one of those things, because I'm chomping at the bit here just to get this done and over with. That's why I'm bringing all this stuff up, because when you're coding, you know, if you're trying to get a project done, extra stuff like this can just slow you down. That's all I want to say right now. That's what I want to get to, or what I want to get across for the time being. So let us go ahead and at the very least try to do something reasonably forward thinking here. So we're going to have sprites that do stuff on the screen is the first thing. The sprites are going to kind of need a couple things. Our character is going to need a priority list of things, and each of those things can be an algorithm, and each of those things are going to need heuristics and costs, which is part of the reason why I did A star first, just as an introduction and I didn't really explain this too much, but obviously the heuristics here, again, we looked at it and I said, you know, it's not really necessary for A star. Yeah, the heuristics are in here, but point being is that a heuristic is basically how good do I think this is going to be, and how effective do I think it's going to be. And when we're going about, when our character is going about the map and figuring out what he's doing, he's kind of got to look at heuristics. He's got to look at his heuristic values that he generates and says, okay, I think I can do this first, and I can do this other thing next, and basically rank things based on their heuristic value. And the algorithms for how to do those things, honestly, are pretty straightforward because we're not doing anything too complex in this. So I planned on having things like an ADD, frankly, meter where, okay, my character is walking around doing something important, let's say, and now he's gonna just kind of hang back and look at stream. That was the idea. And then, okay, there's this, you know, the printer is done, so that has to have a high heuristic value. That's got to be something very important on, or very high on the priority list. So that might, you know, cause him to do exit a little bit early, whatnot, etc. So again, there's a lot of things you could put in this, but at the same time, you could also keep it very simple. You know, there's nothing really stopping you from just getting something that gets the job done. The next thing that we need is actually a way to interact with our sprites as is. So if we look back over here at, it could be either, it could be the sample or the Tinker sample because I did both. This line right here, if printer.animations is last frame, it pauses. So we need to be able to do stuff like that where the printer, when it reaches the end of a print, it has to be able to recognize that, which again is last frame, is a valid and then it also needs a flag, or it needs to have a flag set, one or the other, so that it can start back over. So stuff like that is other things we need to take into consideration here. And again, how complex we set this up in the beginning will determine a lot of stuff, and will determine usefulness going forwards. At the same time, over complexity, as I keep on saying, will just slow us down. So we are going to do our best and see what happens. So. All our entities will be sprite entities, again, just because we have that here. Categories, I guess we could, nah, we don't really have any need for categories. I was going to say, I guess we could do maybe a couple categories, but not really necessary. Also, I note here that categories is not a value here, which is a little bit silly of me. Let's do this. KW. KW. What's our problem here? Oh, one or more keywords. That's right. That would be correct, wouldn't it? And what I also want to do is this there, which is why I put the star in the first time, because I noticed it popping up here. So let's see. let's do a yeah, back to how complex I want to do this. I'm thinking a priority sprite just to have a sprite that, you know, basically, as I was saying, represents our character. It's a sprite that has a list of priorities. And then it cycles through, determines the highest priority, and then pursues that. I'm just thinking about the printer, whether or not the printer is its own thing or whether or not it just has. Yeah, see, I guess I should have thought about this a little bit easier, a little bit more. I was thinking, you know what, we're just gonna go ahead and hop in here and we will get there, but there is a lot to consider. So maybe rather than priority sprite as is what I'm thinking here, priority AI. And we'll make this a mix-in is what I'm thinking. Does that make sense? Yeah, let's see where we go with this. One of those things. And we can pull heap queue in. We already looked at that. You know what? I'm not going to bother with heap queue. A little bit extra bloat that's not really necessary, I don't think, because we're probably going to have to reevaluate our heuristics each and every time. So, probably not necessary. Let's let us priority core. Yeah, all right. So priority queue, I guess we can tag this as being heuristic, and actually I'll go and action. We should probably also have a current action, which honestly that may necessitate a new class sprite. Actually, action entity. Self.current action equals none. Define get action self. Return self.current action. And then this can be, see, I'm hesitating to do this just like this because I can think of a couple ways this could go wrong, but it may not be that big of a deal. So, return action equals super dot get action. If not action, self dot determine new action. action equals max self dot priority queue. I guess at this point, if we're subclassing, then it makes sense to do this. There we go. All right. So it makes sense, right? So we'll have a base action entity, which again, and I don't know about the whole entire making it subclassed on entity, but we'll cross that build. We'll burn that bridge when we get there at any rate, which may very well may happen because obviously we have a conflict here, which is why I was kind of trying to start off with mix-ins because that's less of a conflict, but we'll get there. We'll get there. The fact of the matter is that maybe that was a mistake to begin with. That could have been the mistake to begin with. But we have entities that take actions, okay, and they have a current action. That current action can be assigned by an outside force on the basic action entity. Otherwise, for priority AI, we have a list of possible actions, and then we determine a new action to set it if we do not already have an action. So that does not require the outside force. And come back down here. Key equals. Actually, let me double check while we're doing this. Built-in functions. Built-in functions. Max. We only have key, right? We don't have an actual return value. Boo, boo, doo, doo, doo. Boom, boom. Alright, I do not see an actual return value, so we can, however, use key. Key equals lambda action. Actually, let's say cure action. Cure. HK 0. There we go. And that would be 1 at that point to get the action. And we can just do self.action. Or no, we'll return it. We'll return action. There we go. Pretty simple, pretty simple. Action equals self.action equals action. Return. And just for the sake of, because I'm being lazy, action. Whoops. Cool. Alright. That should be determine. And next, what we're gonna need to do, this is entities. I hesitate to do actions in here. Maybe it should be algorithms. So technically it is an algorithm, right? let's do this. Class action. Yeah, this is the tricky part, right? Because normally I would do class action, callback. Callback always gets the canvas. And a reference to the sprite. Yeah, you know what? We'll do that. I was just wondering, because we have data class in here, was this a simple enough class that I could just go ahead and use data class again? But I don't think it is. I think we're going to need to put a factory in here. So we will go ahead and do that. Define init self callback. Callback factory, I guess I should say. Or maybe not callback factory. Let me start typing and we'll see what happens. Self.callback. Define. Actually, yeah. What if I do call here? Self sprite. And up here. Actually, no, not up here. Not up here. Self sprite canvas here. Okay, this is an idea. So this is function. There we go. This is a sprite. Base sprite. Sprite base. I can't remember. Funny how I keep on forgetting this. Probably because I was inconsistent. Animations, sprite. Oh, it is just sprite. Okay. That explains that one. Where are we at? Here we go. Canvas base. It's definitely canvas base. I know that for a fact. Oh, this is funny. So I imported sprite, but not imported canvas base. Okay. From stream animations dot canvases import canvas base. There we go. That was pretty funny of me. All right, so this equals callback. Takes a generator function which should accept, or not generator function, a function decorator, I guess is the best way to describe it, that should accept sprite and canvas and return a initializes a new action is the more correct way of going about documenting this, and callback. It's funny, but it's been a while since I've done actual documentation for JavaScript, so I can't remember what the correct syntax is for. Actually, what is... Shoot, I'm blanking on the popular software. There's a couple of them, right? There's the one for Google, and then there's the Sphinx. Sphinx is the other one. Python documentation, Sphinx. Yeah, okay, Sphinx. There's another one, though, right? There is... Let's see, Python documentation generator. Let's see what that comes out with. Yeah, Sphinx is at the top. Doxygen, that's another one I recognize. Huh? Wasn't what was the one for Google though? Didn't Google have their own? Huh? All right, whichever. Enough digging around. Back to work. Which is a sprite and canvas and return a function. There we go. A function which representing the action taking, or which how do I say this? Which executes the action for the given sprite and canvas. There we go. Cool, cool, cool. All right. Yeah, I'm not gonna bother. Return self.callback sprite canvas. There we go. All right, all right. Let's see. So there's an argument here. Since we're providing priority queue at the very beginning here, there's an argument here to actually accept canvas as well. Although we'd have to accept canvas and sprite. So I guess maybe not. So right now, the entity here does not have a link straight back to the sprite. The action, so the action we define, actually doesn't have to be a, we could rename this. Let's rename this to sprite action. Which generates actions for which acts as a factory to create action callbacks for sprites and canvases. Or sprite canvas combinations. All right. Yeah, so this is specifically sprite actions. Makes sense to me. Okay. All right, let's take what we have here and try to do something with it, because that's a good way to test out. Save here. Yeah, let's start implementing this. So we'll come back over here. Gonna delete this. define, or I guess rather, come up here. Engine from stream animations import engine. I don't know if I bother doing that. Might just bring this up here. I'm thinking about reorganizing this. So the load walk. We only call this once, so it's a little silly here. So we can instead load character. There's that. Yeah, okay, I did fix that one. All right, cool. Desk. I will delete this one too. We'll put both of these in here. Text animations equals text animations. Delete the parentheses. Monitor text. All right, return desk monitor text. Return printer. Return me. How do I want to handle that? How do I want to handle that? All right, let's do this. Just to keep my life simple. Because I also have the start start locations. Let me check that because it makes more sense to. Yeah, right. That's what I'm gonna do. Okay. We'll just come up here and set the start location. Makes more sense. And let me double check. Canvases. Add sprite. Location is none. Yeah, okay, so that should be fine. Okie dokies. And honestly, this is a little bit of a waste of time. For sprite in SPRs, canvas dot add sprite. Sprite. And sprite is lowercase. F12. Try that again. Obviously, I clicked the wrong thing. Oh, I'm importing the module. That's why. Derp. So I'm importing the module by itself. For SP. Simple enough. Alright. So Canvas has everything it needs, and I clean that up. Now, let us... I'm gonna delete this. Poo. So this was something I was thinking about that we haven't gotten around to. Is back over here in engines. I wasn't sure where I was going to put it, but an overall engine would make sense as well. So something that you can basically put a list of checkpoints into, and then it runs through the checkpoints on each iteration, which the checkpoints being, for example, for each sprite.getAction, sprite.executeAction, whatever. And then, for example, if we got a game with characters with HP, then for character with 0 HP, check HP on characters, remove characters, etc. So just setting that up. But the funny thing about that is back to unnecessarity. What am I trying to say? It's extremely unnecessary. Because the fact of the matter is that such an engine is kind of the top level thing. That's kind of the thing that we just create when we put it together. And there's the concept of it is so vague that it's almost not worth creating a generalized class for it. It doesn't seem. So that's my take on that one. I'm just going to change this to loop instead. Let me check canvas.animate idle sprites really quick. Idle sprites. Okay. So we have to hand it a list of idles. That's good. Which makes sense because there's idles there. So for sprite, and this is what I'm talking about right here. This loop is basically our engine, right? So for sprite in yeah, I think it's just sprites. The only tricky part here is back to our sprites are also going to have AIs attached to them. Let's really quick import that while we're at it. Oh no, we had that imported as engines. Actually, engine is for our actions, so we do not actually. That's under entities. There we go. And this is one of those things where the coupling between the sprites themselves and the entities is about to become apparent, although not necessarily. Let's look at how we have this set up. Actually, the better question is how we have printer set up. So maybe what I should do here is change this to frames 0 printing frames. Do that. Yeah, because this is what I was trying to figure out, was whether or not once this thing goes idle, whether or not that's going to be a problem. Same thing with this, the text animation. Actually, yeah, the text animation is basically idle. Yeah, alright, I accept that one. I accept that one. Because it's not going to have any actions, so that's fine. Okay. Coming together. So instead of sprites for entity in entities, actually no, that's not going to work because again we don't have I was trying to avoid doing this because again it could result in problems later on, but I guess we'll go ahead and do it anyway. You know what? It's not really necessary. I'm going to change that to entity list because our entities is our module. Entity dot get action like that. Result equals if oh my goodness, JavaScript. First I start with parentheses, then I do the explanation point. Not result. Idles dot append, not push. Entity dot sprite. All right. Idles equals that. And then we can animate idles. That's good. And this would be loop here. And we're getting there. We're getting there. So I have decided that this was a mistake right here because I gotta add AI to this, and obviously I'm not paying attention. So me equals yeah, see, I kind of want to, just because there's, in theory, we'd want to be able to hold things in batch. Actually, okay. Let's do sprite still. Just because not all sprites are going to be entities. So, list sprites if result idles.remove if result and yeah, all right, just for completeness sake, I'll do this too. And entity get adder entity sprite. There we go. Just for completeness sake. All right, cool. And in that case, let me undo these things that I did. And this right here, we can say sprites.extends because we don't actually need those guys. And for some reason I erased just because I was clearing stuff out. For sp in sprites canvas dot add sprite sp. There we go. We should keep that. And now we can add some logic. Let's see. Maybe up here, before we do all this, we should create the actions. So, let's see. I'm trying to think if there's a way to generalize. So the printer animation is pretty simple, pretty straightforward. And I'm trying to think if there's a good way to describe it so that we can reuse it in the future without making it overly complicated. So basically my idea obviously is that the sprite, obviously the callback has access to the sprite in the canvas. It doesn't need the canvas, but it has access to the canvas anyway. When the sprite gets to its last animation frame, then it sets a flag. And the flag there is a little bit of a question where we store the flag. That is valid. We honestly, I don't see any. So it's not great. It's not terribly appropriate to set the flag directly on the sprite. At the same time, we can kind of get away with it because, again, at this level of programming, this is rather closed box, right? This program is supposed to run by itself. It's not supposed to be imported anywhere. And therefore, because it's not supposed to be imported anywhere, we can get away with setting the flag directly on the sprite. So we can set the flag on the sprite, and so long as the flag is there, we do not do anything. As soon as the flag is cleared, then we reset our animation to the first frame. That makes sense to me. So yeah, all right, that's fine. That is fine. Oh no, that's right. Our animation has a pause button on it anyway. Yeah, so it depends on how exactly we want to go about this. So the two ways is obviously, like I said, set a custom flag specifically for this animation, specifically for this action on the sprite or somewhere that this action checks. Alternatively, hit the pause button, and so long as the pause button is paused, don't do anything. And hit the pause, and that's that. Honestly, that's simple enough that we're probably just going to go with that one. So, engine. Yeah, we're going to pass the callback in there. So, define single loop. That is not how we do this in this language. Animation. Single loop animation equals engine dot and sprite action single loop animation. There we go. And this is going to get a sprite and a canvas. Define callback. Yeah, we're not passing anything to it in get action. That's something we could consider in the future, passing in more information, but I think that defeats the point of having sprite and canvas in here. I think. I'm not 100% sure. Actually, no, it doesn't. It doesn't defeat the purpose because if anything, I guess we should. Okay, that's the other thing. We could do this on a program-to-program basics. Again, this code that we write here is more or less specific for this specific program, which means that the callback that this single loop animation is expecting can be generic. However, that also means, can be nothing and can be empty right here. However, that means we cannot make this generic if we decide that this is going to be nothing, because future programs may want something. So that's where we're at right now. So if sprite dot animations dot current frame is last frame, that's how that works. Yes, animations is last frame. Sprite dot animations dot pause, right? Or is that in the animation loop itself? Nope, that is not. Dot pause. And we can do this repeatedly because obviously resetting the pause flag doesn't do anything. I'm just trying to think. How do we unpause? Because we'll take an action over here that is unpause. Our guy will take an action to unpause it. And if this runs after that action, which right now it does because we load the character first and then the printer, then we would just pause ourselves again. So I guess we'll have to both unpause and cycle animation. Alright, I think that's where we're at. Alright, printer entity equals entities dot action entity ID of 1. Do we want to? Yeah, we do. Action equals none. If action is not none, self dot. Actually, no, we can just do self dot current action equals action. That's fine. There we go. Action equals single loop animation. And we should call printer canvas. All right, cool. I'm gonna go ahead and move this up. Set up renderer. Put that there. Entity list equals that. Entity list dot push not append. Printer entity. There we go. Alright, we got our first one in there. An hour in of rambling, and we have our first one, but we are well on our way to getting them all done. So, there is that. Oh, this should be a return callback. There we go. So we're gonna go ahead and set up some more actions. I guess just for the sake of completeness, to complete this one right here, we'll go ahead and do unpause printer or collect from printer. Sprite canvas. Yeah, see, we're okay defining this right here because we have access to the larger scope. Yeah, all right. Define callback. If printer is ... I don't have an is pause, do I? I do not. All right, we're gonna add that really quick. All right, now we're going to need from stream animations dot engine dot AI import heuristics algos. Okay, test is the last one, so we don't need that one. This is one of those deals. Right now, we can run a star each and every single time. It's not that big of a deal in our current situation. The terrain is not changing, so we only actually need to run a star once because the terrain is not changing. We don't have other sprites getting in our way. That being said, yeah, I think we'll just run each and every time. That is an interesting topic of when you have multiple sprites trying to pathfind and they can bump into each other. You do run into obviously a little bit of deadlock there potentially, and you got to work around that, but I'm not too concerned. I mean, it's not something I'm going to concern myself with right now, rather. I'd like to say. So, algorithms.a star. Start is sprite.location. Target is printer.location. Adjacent is sprite. Or actually, it should be, but let me double check. Yeah, okay. Right, because adjacent has to include the cost, that's why. I'm gonna go ahead and copy this. There's something else I could do here, but I'm not going to get too deep into it right now. So, whoops, actually that was supposed to be a lambda. Right? Yeah, lambda start. Heuristics. Oh, heuristics is not actually. From stream animations engine.ai.heuristics import distances. There we go. Dot square distance. There we go. And then, let me just double check. We do not have to reverse this ourselves, right? New sprite. We can use direction, but I think we kind of got to... We don't get directions back from this. We get coordinates. So yeah. Gonna have to do this as well. Alright, alright. So that gets us there. The question is whether or not we actually are there, so we should back up a second. So first off, if not printer.animations.is paused, return, because we're not collecting from it. We do not need this at that point, so we will pass on that. The next thing we need to check is if we're already adjacent, is what we actually should have checked first. But I was too excited, so... is that under CS? That might be under CS. Oh, or we do not have that actually built in yet. Two-dimensional, not two-dimensional. Close that. That's tests. We may not have. I may have never actually done the shortcut for is adjacent, because it never came up before. Init. That init rather. Where's my coordinate systems at? Oh, coordinates is its own. That would make sense. Okay. Let's see. So, the mixed direction one is the only one that's going to be a problem. So what we can do is we can determine offset to get is adjacent. Class location. If calculate offset sum calculate offset AB, I guess. Or target. Yeah, we'll just use AB for right now. I'm being lazy. Adjacent to B within offset 1. Across all axes. In only one axis and 0 in the rest. Sum calculate equals 1, and we can just return that. AB. All right, there we go. And then mixed directions. Mixed direction is the tricky one. Let's see. I mean, it's not really, right? It's not. No, it is. It is. Because it's 1 or 2. No, it's not. It's not. Yeah, it's not. Okay. We can do that. Actually, the sum is not going to be accurate. Let's change this. All. No, not all. Not all. Some abs val for val, I guess axis. In. There we go. All right, cool. Cool. Return. Let's see. B does not equal A, or there we go. So we'll do this to just exit quickly, because if B equals A, that will exit true. Or wait. That's not what we want. We want not B equals A. Is that right? So if B equals A, that'd be true. So that'd be not, so we'd continue here. So yeah, never mind. I'm just gonna not be annoying, and I was just trying to add that in there, but it is taking me too much time. So, and I'm being impatient now. So for this one, what was I gonna do? I was going to do all. I was gonna do all. So coordinate system dot is adjacent equals class method And we'll just do this because it's cleaner. AB. Or I guess I gotta do class AB. And this would be all abs axis is less than or equal to 1 for axis in calculate offset. Oh, this should be class.occup. AB. Yeah, so all of them are less than that. And A does not equal B. So for each axis, if it is less than or equal to 1, so it's a 1 or a 0, -1 or 0, for each axis, then that means it's adjacent because it's not further away from 1 than 1. Oh, calculate offset is... shoot me. Calculate offset only returns 1s, and so we actually do need... Okay, so we won't be using calculate offset, is what it comes down to. Let's see. A axis minus B axis for A axis, B axis in zip AB. There we go. So that should do it. And I'll copy this down as well. So -1 minus -1 is -1 plus 1 is 0. -1 plus 1, or -1 minus plus 1 is -1 minus 1 is -2, so that makes sense. Plus 1 minus -1 is 1 plus 1 is 2. I'm just running through the scenarios to make sure I've got this right in my head. Alright, I guess that is correct. One of those things we will find out later, I guess, if I screwed that one up. So, back to this. So now we know that the printer is paused, and if sprite.cs dot is adjacent, let me just look at that really quick. Yeah, AB. So sprite.location, printer.location, printer dot animations dot unpause. There we go, and return. So we're adjacent, we hit the button, we're good. Actually, no. Printer.animations.cycle. I gotta remember to do that one. And then return. And I'm getting this because... Huh. Why am I getting that? Expected colon. Don't know why. Let's see. We got a colon here. If pause colon. If. I'm not sure what you want from me, bro. Alright, otherwise, we gotta move. So anyway, that is where we're at right now. So that completes that algorithm, that AI right there. Define, or actually let's turn that into an action really quick. Engine dot sprite action. Oh, actually, return callback. There we go. This is not red. Next question is... Huh. Find callback. Let me hit the delete button here. Huh. What did I do goof up? Okay. Return callback. Define. Fascinating. Fascinating. It's up higher. It's saying it's up higher. Nope, it's still down here now. Save. Huh. All right. Well, that is frustrating. Oh my goodness. No, that's right. I was gonna say, wait, no. I'm going to do this. Okay, well, evidently I have a circular reference. That's always good. So over here in Engine, we import canvas base, which is why I was not importing canvas base before. That explains that one. Okay. So that solves that issue there. Let's see. Well, evidently also that is incorrect. But so far I don't have a syntax error. Self.categories equals list categories. Oh, okay. Over here in entities, if categories is none, categories equals list categories. Or no, equals list. There we go. All right, yeah. So it's funny, I just spent like what, 5-10 minutes there? And Python says that you are drunk. So I'm going to ignore your squiggly lines because evidently you are wrong, because Python says that I have nothing wrong with my code at this point. So I'm glad for feeling stupid for a minute there. Thanks. All right. Collect from printer, blah, 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 blah. Next up, we can... let's just put a random wander in. So define wander. Define callback. This should be sprite canvas. Let's see. Actually, no. Nah. I guess that doesn't make sense. So this, I think, is going to... I talked about that. I actually do recall talking about this at one point. At least touching on it at one point when we were doing random movement. I said technically it really shouldn't be random movement because random movement doesn't look proper. Really it should be walking in like one direction for a little while, so it should be a weighted wander is what I believe I said. So how do we implement that? That's an interesting one to implement because that does need past actions and back to storing data on the sprite. Yeah, I guess that's what we'll do. So equals sprite dot valid directions or valid moves. Okay. Valid moves. If get sprite. Oh, actually, we can do this first. Sprite dot wander history equals list. Yeah, that makes sense. Okay. It does not make sense. Oh, sorry. So, it does not, but that's fine. Do we have random in here yet? We do. All right, cool. Let's see. What do we want? Let's say 10% per wander. Okay. If sprite.wander history and sprite.wander history 0 in directions do I want to do something different here? No, we'll start with this. Actually, new direction equals none. If not directions, return. Return false, I guess I should say. That's right. We should be returning here. So, return true. Return false, and we moved here, so this is return true. Again, actions should return whether or not they did something so that we can check it with result here. Idle.remove. All right, so if we have a wander history, so if we were walking in a direction and that direction is still a valid direction, then we check if random time. Now we don't have to do times. Random is greater than, let's say we want at the very beginning an 80% chance, let's say, to continue moving in the same direction. So that's like 80 minus, or it would be 90 minus. It would be 90 minus length sprite.wander history. And that would be divided by 100 to get us between 0 and 1. And that actually should be less than, and this should be min, or I guess max rather, max. So make sure that we don't go negative 0. Sounds correct to me. New direction equals let's see, sprite.wander history 0. How do we want to build this tree? if not, oh, not directions. Not sprite.wander history. All right, so we'll do this one first because that makes sense. New direction equals let's see, random.choice directions. And there we go. That takes care of that one. So in this situation, we know that we have a wander history and we are not going in the same direction, so we have to go in a new direction. So else, I normally don't like doing if else trees like this, but I'm going to make an exception for right now because tonight has obviously been a little bit of an impatient derby stream. So else directions dot remove sprite dot wander history 0. Actually, no, we shouldn't do that. New direction equals actually or length directions equals 1. If we only have one option, then we obviously just take that one option. Else, if sprite.wander history in directions and random else, so either this else is either we're not in wander history or we failed. If we failed, we really shouldn't select the same one, but at the same time, that adds an extra if check in here because of the way I structured this. Therefore, we're not going to worry about it. So new direction equals random.choice directions. All right, cool. If new direction does not equal wander history 0, wander history equals new list, and then wander history dot append new direction and sprite dot or canvas dot move sprite, canvas dot move sprite, sprite direction equals new direction, and all of a sudden my highlighting has gone funny again. Length directions does not equal, there we go. I'm glad the highlighting hopped in there again. Yeah, it looks like it fixed itself up here. Couldn't tell you why, but canvas.move sprite can take a direction, right? Yes, can take a direction, and valid moves are directions, right? Yes. All right, cool. We good there. So return true. There we go. Wander equals engine dot sprite action collect wander. All right. Now we need a heuristic to get us to a functional place. So again, this is going to be a bit more complicated as we go further into this. This will get a bit more complicated, but I want to get at least a working idea in here. So we will just make a heuristic at this point, which is... Or actually, it should be a priority queue, right? Yeah, so it should be a priority algorithm. Boom, boom, boom. All right, so collect heuristic equals, I forget. So infinity is, I guess I don't need infinity. Lambda. If printer, let's see. $1,000 if printer dot is paused, else 0. Wander heuristic equals lambda 10. There we go. Very simple. This we should figure out more about that stuff later on, but like we should make that more specific. Let's see if actions take sprites in Canvas, then maybe the heuristics also should. I don't know. Again, we'll burn that bridge when we get there. So. Me entity equals entities dot priority AI 0 priority queue equals, actually let me just make that me priority queue equals collect heuristic, because we're doing heuristic first, and then collect from printer, wander heuristic, wander, there we go. Actually, what am I doing? Me priority queue, and yeah, I don't need anything else. Entities list, let's, yeah, that's fine. All right, let's see. Last thing I realized that we need to do. Actually, we should always be returning false here. So. Oh, no. But we're going to return true. Yeah, we want to return true. So. Return true here. And we'll return false here. Okay. Alright, let's see what happens. Alright, printer is not printing. That's cool. Text is not going across the screen. That is also cool. And if I check the... Oh, has no attribute priority queue. So, back over here. This needs to be priority queue. Alright, cool. Let's run that again. Check our... Huh. has nothing. Oh, okay. Oh no, I just derped me. Okay. I just went and closed my PowerShell window. Let's see. Back to stream animations. PowerShell.m scripts activate. Alright, cool. We are back in what you call it, and evidently somewhere in here I tried calling is paused instead of animations.is paused. Animations is paused. Sprite.animations is paused. That all looks correct. Oh, printer is paused. There we go. And what's our next error? Sprite and canvas. That does not make very much sense. Boom, 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 boom. Oh, I guess it does. Let's see. Where are we at? Where do I add those actions? There we go. This is me canvas. All right, try it again. And still nothing. None type is not callable. Good. Wander. Return callback. There we go. Good old debugging times. What do we got now? Valid moves is missing engines. Valid moves. Huh? Engine. Oh, that needs to be canvas. Okay, gotcha. I forgot. Canvas. And okay, evidently that is a generator. So we need to case that as list. And handle move. So we're trying to move. Let's see. Huh. Sprite.location is none. That doesn't make terribly much sense. Because we set sprite.location up here. Print sprite.location. Let's see what happens. Alright, nope, it definitely has a location, so that is very odd. Why are we getting a no location? Sprite with self at location. Oh, at location none. Okay. If at location is none, at location equals self.location. There we go. wander history accessed before assignment. Sprite.wander history. Huh. I seem to disagree. Did I misspell it? Is the next question. This is new direction does not equal. Oh, okay. If wander history and there we go. Oh. Sprite dot. I see what's going on here. Whoops. Boo, 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 boo. Huh. Alright, so this should have failed, which is interesting. Get adder. Oh, wait. Get one of those things back to built-in Python. I may have been a derp face here. Oh, okay. Get adder, you actually do have to. Okay. You do actually have to provide default. My bad. None. Alright, so that's that. But that popped up because after we did this, me entity dot sprite equals, because we're still not handling that right now. Again, that's something that I'm still sorting out about whether or not I want that to all be interconnected. Alright, we definitely moved. That's a good sign. Huh. Interesting. Evidently, that was actually just stuck. I thought we had an error, but alright, there's us moving. And then I try to minimize this, and it is actually just stuck. Fascinating. Close. Wonder what we get stuck on. I mean, it looks like we get stuck on a wander because the printer is not actually moving, as best I can tell. Although that could be incorrect because we're only getting 3 frames in. Do. Okay, it looks like we're actually getting stuck on the very first loop, which is interesting. So we render, we get to the root after, and then somewhere right here we're getting stuck, it looks like. And this is one of those things where this is why, yeah, we get to the second here. We get to a get action. And this is why I stopped actually coding live, honestly. Is because sometimes I do get a bit derpy here. I'm gonna have to admit. And it's now been, close to 20 minutes debugging this. And I'm not sure how entertaining this is. Noticing all my flaws. The odd thing is that we don't have any for loops in here, right? The only for loop is in valid moves. But we don't have any other for loops to get stuck in. No for loops, no while loops either. A while loop would also be a problem, but we don't have that. Huh. Start end here. Huh, so we don't actually get into the second wander callback, which is interesting. Which means that we're getting stuck down here. Entities list. Idols is list sprites. Entity got action. We don't modify entity list anywhere, so that's not the issue. This is the last debug print I'm going to do, and then we're going to call it a night. Entity result. Assuming this doesn't give us anything to go off of. Alright, so we are here. We are here. Priority AI. Action. Action equals super get action. Determine new action. A max self priority queue. So we're getting up to here. We go call get action. Get action we saw last time does not get to the start, so it doesn't actually call wander again. So it doesn't call the wander callback unless it's hold on, let me hit Control Z a bunch. See where I had that start. I thought I had the start right underneath callback, but yes, I did have it right underneath callback, so it doesn't even get to the callback. So we get to get actions right here, and we do not execute this, is what the debug is saying. We get to here, we get action super dot call action, or get action, return self dot super action, or self dot current action. Actually, this is an interesting problem, I'll admit, because I just realized that we set the action here. We're not abandoning any actions, so we would actually be in Wonder for forever, technically, the way we got this set up, which is a problem. The question is... Yeah, you know what? We can just get rid of this. Return self.determine new action. Oh, I should do return action. Do this. If not, yeah. All right. We'll try that one more time, see what happens. Still hanging up. And yeah, we are still stuck in the same place after changing that up. So, all right, yeah. So I think that's it for tonight. We did hit the 2-hour mark. Admittedly, it was a much less focused stream tonight than normal, which I don't know. It's a different style at any rate. Not sure how I feel about it. It feels a little, especially when stuff like this happens, I kind of regret it a little bit, but I guess it's not the end of the world, and I guess it is, content. So, fascinating that we're not getting this far, is all I'll say. Fascinating, because determine action is just a max on the priority list, which is just a tuple. The tuple calls very simple heuristic values. Which were right... Where were they at? Right here. So, yeah, I mean, this is just lambda return 10, and this is just 1,000 or 0. Yeah, it shouldn't have any problem calling those functions. So, it's very odd. Me priority queue. Yeah, I guess I'll find out off stream, and when we come back, it's one of those things. We have most of everything we need in here. Just a couple more functions to make our character more alive, I guess, is the only really thing to add. And then I also wanted to, for the stream itself, add little bars and whatnot. Like I said, as I alluded to, ADHD bars. Just indicating, okay, this is, it's getting to the point where the character is going to do something else. And I wanted to have like a counter for how many times the character collects from the printer, for example. So I wanted to do stuff like that. I figured that would be fun. So all that stuff is on the way. And otherwise, yeah, I guess that's it from me. So if you guys have been watching, thank you. And I hope you have a great and wonderful day, afternoon, or evening, wherever you are in the world. And I will catch you next time.